Hello, everyone. On behalf of HowToRobot, thank you for joining today's webinar, How Robots Improve Quality in Stainless Steel Manufacturing. My name is Ryan Shook, and I will be your moderator for today. Sohabe Richyal, a robotics and automation consultant, will be presenting. HowToRobot is a global marketplace of robotics and automation. We help manufacturers who are looking for ways to automate, find the right partner in a confidential, independent, and streamlined way. If you're interested in learning more, please don't hesitate to reach out. If you have any questions during today's session, please write them in the chat box, and we'll have a few minutes for Q&A at the end. If we don't have enough time to answer your questions during the session, we will follow up with you afterwards. We will also share the webinar recording and the deck with everybody after the session as well. Thank you to Rob, Kate, and the BSSA for having us speak today. Rob, I'll pass it to you for a few words before we get started.
Okay, thank you very much, Ryan. Appreciate that. Good morning, everybody. Hope everybody's feeling okay this morning. I think, Ryan, you are over in Chicago, so it's a very, very early morning for you. But thank you so much for joining us. Anyway, for any of you out there joining us today that don't know me, I'm Rob Cooper. I'm the director of the British Stainless Steel Association. And, you know, I feel very fortunate. Stainless steel is a really interesting and developing metal for us in the industry overall. And we're seeing year on year stainless steel growth increase quite dramatically. You know, it's gone up from around 25,000 tons at the 25 million tons at the start of the century, now to over 50 million tons a year global usage. The UK, however, our consumption basically has been stable for many, many years now. Certainly since pre-Brexit 2016, or the start of the Brexit process, whilst globally consumption continues to increase by about 5% year on year. So why is this? There are a number of reasons behind it. Part of it is lack of investment, both by government and also by private investors. We've had quite a lot of offshoring of businesses over a number of years, but also we've got real problems like lack of training opportunities, loss of skills. A lot of our skilled workers are retiring now. And the fact that, you know, overall manufacturing isn't considered a very sexy industry to be in, and particularly the steel industry. So hopefully with the introduction of robotics, automation, etc., our views will change on this. And HowToRobot are here today to help us maybe grasp some of those opportunities that are available for us within this industry. You know, if we can increase the use of robotics and AI in fabrications, you know, it might help to offset some of the skills losses that we're having, and also maybe improve our productivity, our quality, etc. So, you know, hopefully we'll get quite a bit out of that today. So, to Ryan, to Sohabe, please, would you like to tell us a little bit more about HowToRobot?
Thanks, Rob. Yep. So I'll just I'll start straight away. Hi everyone. So welcome to today's webinar. The topic, as Ryan said, was how can robots improve quality in the stainless steel industry and stainless steel manufacturing. So since stainless steel industry, like many others, is facing challenges as Rob just mentioned in the current economic climate, so labor shortages, material costs, energy costs, and greater demands from customers. And it's increasingly relying on robotics and automation to help alleviate some of those issues. And now is the best time to either add automation or increase the amount of automation that they currently employ to help them become more sustainable and more competitive in an environment that's just getting harder and harder to be competitive in. But to do that, you have to understand which processes are right for automation. So which processes are right for automation, which ones are suitable for automation. You have to understand what's the average cost for those solutions and what's the return on investment, potential return on investment for them as well. But you also have to understand how to find the right supplier and, you know, which suppliers to work with and kind of where to look for them in the first place. Hopefully some of the next few slides will explain some of the challenges, some of the issues and some of the opportunities that we can see. But just before I do that, as Ryan mentioned, HowToRobot is a digital marketing platform. It connects buyers and suppliers of robots and automation solutions. It's a digital platform, so it's accessible worldwide, and we work by connecting those companies that need automation or robotics with those suppliers that can, and they're qualified. And there's a fast-growing network of about 16,000 of them that we can work with. We also help by providing kind of marketing insights, guidelines, and digital tools that can help those companies find the best solutions that work for them. So my name is Sohabe Richyal. From a background point of view, I've worked both within the petrochemical industry and also robotics. My background is in both, so I hold a master's degree in both those topics. And previously, I've worked in both those capacities and worked within the nuclear sector, developing robotics and teleoperator equipment for harsh environments, in this case, a nuclear reactor, but also space applications, deep sea. And I joined Gain & Co, which is actually a sister company to HowToRobot. So I'm just presenting on their behalf. But I joined Gain & Co to help bring some of that knowledge to clients and help them along their automation journeys, and hopefully get some of the solutions that are beneficial for them and help them improve. So improving quality, how can automation help? Well, first of all, there's many definitions of quality. Some are more objective, some are subjective, but they're interdependent. And if you look at, if you pick up a dictionary, look at the definition, the kind of key concept is that quality is a degree to which an object or entity, a process, a product, a service satisfies a specified set of attributes or requirements. Basically put, it refers to some inherent properties of an object that allow it to satisfy some stated or implied needs. Furthermore, if you think about quality in different terms, it can also be in the context of goods or services, and it's the perception from a customer's point of view and mindset about those goods and whether they've met a particular kind of need for that customer. So in terms of manufacturing, what are kind of the key areas that we can focus on? And these first few are not specific to any one industry. They're more kind of general ones that we can look at. So first of all, material handling is one area. Whether it's raw material or finished goods, you need to kind of look at or consider how the material is handled. Does it get damaged during the process or transport or storage? And this is one key area that we can look at for improving quality. Machine tending, so is the parts or are the parts consistent, uniform and always the same? Are they handled and provided to the machine or process in a predictable manner, always in the same orientation, always in the same location, with consistent and uniform? So how that is kind of carried out is another key area to look at for improving quality of the product as well as the process. Painting and coating, so hopefully this one's obvious. So physically, is there uniformity, consistency, coverage of the paint? But what about the material itself that's used? So how is it stored? How is it transported? Is there degradation of the kind of paints over time? Picking, packing, and palletizing. So warehouse management systems, pick to light or pick to part systems, goods to person. These are all going, a long way in helping improve the perceived quality of a product as well as the process itself. And the next one, assembly. So again, another obvious one, machines can assemble parts faster, more uniformly, more consistently, and again, help to kind of increase that perceived quality for customers and also other users of that project. Looking more specifically at kind of stainless steel and steel industries in general, there's also the finishing process. So this is a key area where automation can help removing an operator from kind of intensive, labor-intensive, hard jobs, sometimes in harsh environments as well. But things like cutting, grinding, deburring, finishing and polishing, all these jobs are very difficult to do or very time-consuming to do, and automation can help relieve that operator to either go do something else or just generally help them not have to do these jobs for prolonged periods of time. We've been to clients where particular operator is grinding parts for 8 hours a day, and by the end, they can't feel their hands because the machines are vibrating in their hands all day. So yeah, nobody wants to be working in that kind of environment, and automation can help remove that. And then the one that more, most people think of is quality and inspection. So vision systems, touch sensors, force sensors, all these things can help speed up the process of quality and inspection, and also add to the fact that your end product will be more consistent, and again, add to that kind of quality that customers want to see and then, proceed to see as well. Okay, so those are the areas we can focus on, but automation and the automation industry is no different from any other, and there's always challenges to adopting a new technology. So what are some of those for automation? Well, first of all, you need to understand the needs and your particular needs and where you can apply the technology. So incorrectly implemented automation will cost you a fortune and just create massive amounts of frustration. And frankly, it makes people quite scared to adopt new technologies, because we've seen a lot of companies in the past that have attempted to automate some process. They've had a negative experience, and now they don't want to try anything new. So this is one kind of area where people go in a bit blind, and then they get, they don't have a good experience. Knowing the limitations. So you have to know the limitations of the available solutions. So you have to know the operating environment you're in. Is it hot? Is it cold? If it's hot, what is the temperature? You have to know the specifics. There's a massive difference in applications for an ambient temperature operating environment compared to, say, a nuclear reactor where temperatures can reach up to 150 million degrees. So you have to know the limitations of the technology that you're trying to implement. You have to take into account, are the parts, wet? Are they dry? And is there kind of machine coolant flying around everywhere? Again, these will all impact the kind of the way that the process is carried out, but also will be limitations on where you can apply certain types of technology. And then you also need to look at things like the process cycle time. So, if you're thinking about a 10, 20 second cycle time, that might be really slow for some people. That might be super fast for some people. All of these things need to be taken into account when you're looking at the limitations of the available solutions. Getting a reliable cost of operation and a return on investment estimate as well. So when you're looking at automation, it's not simply just the cost of the hardware that you can have on your shop floor or your factory floor. You need to look at the installation cost, the running cost, training, maintenance. All of these go into the total cost of operation, and a lot of times people, fail to understand or fail to take that into account fully. So you need to know that can also go into the ROI estimate as well. When you look at the ROI estimate, is a lot of the times the companies will just use the kind of direct labor reduction or direct manpower that's affected to do the ROI estimates. But a lot of the times the benefits come not just in that particular area, and you need to look at the overall kind of equipment efficiency to see where the other benefits might be. So you may not directly reduce labor, but you may, as I said, you may be able to redeploy those staff in more higher value tasks or more urgent tasks, or just get them away from an environment that's dangerous or harsh, where they don't want to be working. So those factors need to be taken into account as well. Being able to speak the seller's language, in this case, the seller being the automation suppliers, or the vendor's language, and also them being able to understand the terminology that you use in your industry. So there needs to be clear, concise, and effective communication to make sure there aren't any kind of misapplications or kind of confusion, or worst case, assumptions that are used that are wrong, and then you end up with a solution that isn't right, that isn't effective, and isn't doing what you want it to do. In that case, it goes back to that negative experience that companies have faced in the past. So yeah, this is a key area that sometimes gets overlooked quite a bit. Gone too far there. Getting people to be comfortable with the fact that they might be getting a robot colleague or automation solution in place. This is again another area that's often overlooked quite a bit. Yes, in some cases people are anxious about losing their jobs to automation and robotics, but actually the vast majority of cases that we've seen, people are quite excited to be able to work with robots. They're excited about kind of upskilling and learning new techniques, or learning about maintenance, or just learning about new technology in general. The key point here is to make sure you have effective communication between yourself and the staff that are going to be directly impacted by this, and make sure that they're kind of involved in the whole process. and just make sure that they're aware of the implications that this will bring. And actually, a lot of the times they don't end up losing their jobs because they just get redeployed to somewhere else. Okay, before you automate, you need to ask yourself a few questions, and this goes a long way into hopefully letting you understand if you are ready for automation. So the first of those is, are your processes actually under control? So are people having to open and close doors manually or frequently? Are they having to stop operations, reloading machines, or recalibrating them? Another way to think of it is that if your process is really under control, you don't really know what's happening or what should be happening consistently, then adding automation isn't going to help and actually will just increase the chaos. So again, we've seen examples of where companies have automated a particular process, and all that's done is just create a massive bottleneck downstream, and operators can't keep up. And again, the system's just either not effective or just turned off, or sometimes it's even slowed down to make sure the operators can keep up. So if your processes are not under control, then that's something you need to look at first and ask yourself, how to do that. Automation can help make processes more reliable, kind of more predictable, more repeatable, but you need to make sure that the human element is also taken into account. What's the current schedule loading of the machines, and what's the current operating equipment efficiency of the equipment? So you may look at your particular machine on a particular shift and it might be 100% utilized, maybe. But actually, when you look at the entire operation of the plant, you might realize your operating efficiency is not actually that high. Being able to get those machines running 24/7, without human intervention, that will help increase your utilization. But you need to make sure that you're looking at the right kind of processes and the right times, and not just kind of looking at a tunnel vision of just one machine, one process, because that won't give you the right information. Are your machines automation ready? So we'll dive a little bit more into this in the next slide, but is there space? Is there the correct interfaces? Do your machines need upgrading? Are they 30 years old? Are they obsolete? Will there be parts? You need to make sure that there are all these kind of inherent questions you ask about whether your machines are actually ready for automation before you start buying kit, because a lot of the times you can't simply just plug in automation into a machine and expect it to work. There is a bit of work you need to do. So you need to ask the question if they are ready. And automation ready, part of that will also play into are there any space and physical layout restrictions? So I've been to clients where the space up the corridor is so narrow you can barely fit an operator. There's no chance you're going to fit a robot with all the safety equipment, the fencing, the light guards that you need. And so you need to take into account whether there's physical restrictions like that, and also how are you going to actually overcome those. A lot of operators of automation are now making kits and tools that are can be retrofitted to current machines, or they fit inside current machines. But even so, you still need to take into account the kind of restrictions that physical space and layouts will bring. How well does the automation solution perform the job? So here, what you need to look at is you may be able to automate an individual process 100% of the time, but when you look at the whole system, trying to get that last 10 to 20% where the highest cost comes in, it may be appropriate just to focus on a smaller part of the process and not try to automate the whole system, because you might realize that you get a lot of work done for just a small kind of investment in a small area of the task. And so we call this the low-hanging fruit. So if you have a holistic view of the entire process, you can see, I don't need to automate the entire process, just focus on that one little bit and get most of it kind of covered. And then also it goes into the kind of backlog bottleneck issue as well. How will the automation actually relieve the people doing the job? So you need to understand, what are people doing? How are they doing it? How should they be doing it? And will automation actually relieve the person doing that particular task? So, you may have a process where it's one person, one machine. So when a part is in a machine or product is in there, the operator needs to stay close by or tend to the machine. Well, will automation then help you be able to have, one operator tending to 5 machines? Is that a realistic kind of way to look at it? But you need to understand, what will the automation actually help achieve? Again, if it's not You may be able to automate that process, but then if you need an operator to manually do something before or after, well, then your automation is not going to be as successful as you'd hoped. Which automation solution provides the most value for money? So to truly kind of understand the impact of automation, you need to look at kind of what are people actually doing, and what will it, what will the automation bring? And it necessarily isn't always kind of direct labor reduction or direct financial benefits. It might be kind of improving safety, or it might be improving the working environment. So you can think of this as from a point of view of performance or operating efficiency, uptime, simplicity, or speed of change. But there are sometimes a lot of other benefits that come that aren't necessarily financial. In the past, it might have been the case that if you run a massive batch size and you reduce the amount of times you need to change over your machine, well, then your utilization's high. Okay, great. But now we can see some automation machines where the changeover of the tool is as quick as the changeover of the next part coming in. And so you don't need to worry so much about that. The other thing you need to look at is the kind of flexibility and variability of your the automation that you want in place. So we've been to clients where they have maybe like 10, 20, 30 variations of cardboard box that they use for packaging. Now, you can get automation that can deal with that level of flexibility, but the cost will be prohibitive. It might be better to optimize the packaging to say 5, 10 sizes of boxes, because then you can have a much simpler solution, a much cheaper solution, and actually get a better kind of value for money from there. Is your safety in order? So clients, for some clients, safety is top, for some it's not. You need to take safety into account. You need to look at kind of risk assessments. These are important to carry out for you, your staff, and the suppliers that you're going to be working with. You need to look at where you can improve safety before you even think about automation, because sometimes that might not be in place. You need to pay kind of close attention to what and who will be around automation. So having the appropriate kind of barriers in place, whether they're physical or training or whatever, they need to be in place as well. And then a lot of companies simply just think about the operator that will be around the automation. And they say, oh, that operator is capable, they've had the correct training, they won't do anything unpredictable. Yep, perfect. But what about the staff that are for maintenance, or the cleaners, or the receptionist, or the random postal guy who's made it onto the shop floor? They're not necessarily aware of the safety implications of their presence. And you need to make sure all those kind of things are taken into account before you have robots that can lift 20, 30 tons swinging around. So you need to think about safety from a whole factory perspective rather than just the particular process you're automating. And then does your staff need training, or what kind of training? So you need to look at the requirements that you have for them. How are you actually going to train them? Or are you going to train them on the maintenance of the machine as well? Do you need to think about what areas they need to train on, and how, and who will actually provide the training? Is that going to be internal or external? That needs to be taken into account as well. So are you just going to have the equipment and the staff running the machine, so they just press the button and walk away? Or do they need to have the skills to be able to fix it no matter what happens? So those need to be taken into account. So these are just a few things to, and then finally, are people comfortable with working with a robot colleague? So as mentioned before, people may be anxious about losing their jobs, but actually a lot of times we see that they're quite excited about working with it. Clear, effective communication, and making sure they're involved in the activity of bringing automation on usually helps alleviate those worries. So these are just some of the questions to ask before you automate. Going to the point about, are your machines automation ready? You need to look at whether your toolware is predictable. Can breakages be sensed and measured? If they are measured in a certain way, how is that? Are you just seeing that products are coming off that are then ending up being rejected, or worst case, is the machine shut down? You need to make sure you have a good understanding of where that is occurring. And then this goes back to having those processes under control as well. What about access? So things like access doors, are they automated, and do they open and close automatically? And then also, it's not just about opening and closing automatically. Do you know when they're open? Does the robot know when the doors are open or the access is there? Because if it doesn't, it might just end up driving through it, and then you have another issue to deal with. Is work holding consistent and automatic? So this goes back to the first point about are the parts coming in a consistent fashion, in the same orientation, in the same location, because that will go a long way in making sure automation is actually successful, rather than having to have massive variability in your machines. From an automation point of view, if that's all consistent, then you can have a much simpler solution. Debris management and waste management is effective. So things like fine particles, dust, shrapnel, swirl. It goes into the work holding, but you need to make sure the area you're working in is clear. It poses another chance. It goes above. Lots of automation solutions can include items to wash the surface. So things like wash cycles or air jets on the end of robot arms. Or other factors to help clean the area that the part or the product is going to go in. But you need to take into account that you might have to add in extra time in the cycle to be able to allow the machine to do that. Sometimes I've seen where the debris has caused a huge problem where it's got stuck in a belt, for example, and now the belt's not moving, and the sensor thinks the part is in a particular place, and it's not because the belt hasn't traveled as far. And the worst case of this example was where we had a part was traveling along an a conveyor. There was debris stuck in there. The belt was slipping, and the sensor thought the part was in a particular place. It wasn't. The gripper went down, tried to pick it up, and it drove straight into the belt. And so, that's the worst case example. But things like that can happen, and you need to take into account that a simple bit of debris can cause that. Hardware and software interfaces, are they in place? Have they been tested? Do they need upgrading? These are things that you need to take into account, because sometimes you might find your controller for your machine is obsolete, or you can't get the maintenance parts for it, so you may need to upgrade that. Software glitches, I come from a software background as well, so yeah, those are the bane of my life, and I don't think they'll ever go away. And then machine performance monitoring. So you can monitor your machine, and it'll definitely give you visibility of the performance of your machine, but it's not always required. You can quite easily automate a standalone machine and have it running and get the results you want without having the overall performance of the whole process. If you are going to do it, you need to make sure the data you're getting off and the data you're measuring is actually useful, rather than just just for the sake of measuring. Okay, so now the crux of what we want to cover. So the top 5 most ripe opportunities of automation. I realize I'm running a little bit over time, so I'll speed up a bit. So CNC machining and machine tending. So these are applications that they actually, some of them are quite easy to automate, and development of things like cobots, where they can automate the loading and unloading of parts into the machines. That's seen a huge rise in that development. And they also need work holding as well, so they can work quite well with the automated work holding as well. Forge press or forging press load and unload. So this is a perfect application, because the working environment here is often kind of extreme pressures, extreme temperatures, and this is perfect for robots to take over, because it's a harsh environment that people don't really want to work in, and it can cause a lot of injuries if it's done wrong. So removing that person from that particular job will be a good application for automation. Heat treating and loading and unloading. So again, often the processes here are, the motion is relatively simple, so automating this will be quite a good one. But again, it's that whole extreme temperatures, extreme pressures to try to remove that person from that harsh environment. Assembly, inspection, and kitting. So vision systems can be employed to kind of see if there's a part there, so part presence or lack of, and if it should be there. Assembly from robots to do assembly is quite a big area as well, where they can manufacture and assemble quite dexterous parts. So we've got clients where they manufacture medical devices, inhalers, and things like that, where it's sub-assemblies of 5 or 10 components, and they can put those together quite fast and in a very consistent way. Racking, packing, carting, and palletizing. So this is a ripe opportunity for automation. Often this is an area that we can make the most impact, because it doesn't usually require that much modification. And warehouse management systems are playing a huge role in making sure that the kind of perceived quality for the customer is there, because if they get the product, as soon as they order it, and they think it's a good quality product, then they'll think the service is good as well. And this area is very mature, so there's lots and lots of solutions. And metrology quality checking can cause massive backlogs, especially if you're processing a lot of parts for kind of medical or military applications. They can take long times to validate, and their tolerances are extremely narrow. So you need to make sure your parts are very good. There's countless examples of automated machines here where you can simply buy it, roll it off the delivery truck, and within 1 or 2 days you're up and running. And combined with automated loading, this is quite a good application. Right, so if you plan in advance and prioritize the ones you want to work on based on the risk profile and the speed of install and payback periods, then you can kind of look at the payback periods and see which ones are the most kind of ripe ones to attack first. Now, when we talk about application and risk level, what we mean is the following. So these are internal kind of ratings. I mean, the terminology doesn't mean too much, but the explanations are what are going to be there. So an A1, so the green one there, is an off-the-shelf solution, something more or less that's standard, requires very little modification. You can buy it and bolt it down, and you'll be up and running in no time. So for an A1 project, typically the payback periods are less than 1 year, and the delivery times, they are usually the fastest to deliver and install. Operator training is minimal, and you can be up and running in about 20 weeks. So it's a very standard solution. A2 is something that would require modification. So it would more than likely be an experienced integrator. So A2 projects are ones where you need modification to either fit your process or your kind of your operating environment. We recommend you get an experienced integrator because you may not necessarily have the resources that you require in-house, so staff with the correct knowledge or the time or money as well. We find that A2 projects, at least if you want to try to do them yourself, typically your cost to implement that will be much higher, whereas an integrator, at least one with an experience in a particular field, will their cost will be considerably lower because they've done these projects quite a lot, so they'll know exactly what pitfalls to avoid. And typically we're looking at payback periods of around 1 to 3 years with the kind of slightly longer delivery times, 20 to 30 weeks for installation, commissioning, testing, etc. And then A3, these are the most kind of complicated solutions, so bespoke, developed for that particular application, and they're the longest to deliver, so around 40 to 45 weeks, and 3+ years of ROI. Now, I want to point out one thing. So some integrators and suppliers, their lead times are 12+ months. That's kind of an issue of COVID and supply chain shortages and chip shortages and everything. So those timescales up there are general. And I want to emphasize that those are for kind of more common processes, because anything involving R&D, that's a different game, and you might not get those payback periods. Right. So going back to the ones that we pointed out, then none of them are A3s, one of them is an A3. Most of the other ones are very kind of, there's applications in there. You can go as simple as an A1 for things like CNC machining. You buy a cobot which can be trained to load and unload, or if you want to have the whole process automated, it's going to have slight small modifications. So CNC machine tending, there's lots of application that can be retrofitted. And you can employ things like cobots to make it easier. Metrology has applications where you can simply buy the kit, have it delivered, and you'll be up and running in a day or two. Assembly and packaging, again, I mentioned warehouse management systems, warehouse automated systems are very mature. Things like automated storage and retrieval systems, they've been developed for a long time. The only one that's complicated is the forge press load and unloading. So this is mostly due to the kind of the temperatures and the pressures and the operating environment. But again, with enough R&D and with enough kind of scope and cost, you can automate that as well. So just final slide now. What's the 5 steps to automation success? So the key to is to try to follow this step and hopefully narrow it down. So first is to get an overview and create a roadmap. So try to understand, to make a plan and prioritize what steps you need to take. Sometimes the obvious place to start, it's not so apparent unless you sit down and map out your whole process. And so that's where you should begin. Next is to confirm the financial performance, current and realistic, current performance and realistic potential. So there's two ways to look at this. One is purely from the cost point of view. So, what's the budgets for automating? What's the payback periods? What do you want to see? Are there any restrictions in terms of supplies and costs and things like that? The other way is to look at the performance of the machine, both current and the incremental increases you want to see. And so you need to look at whether, if you automate a particular process, can you now run extra shifts, or can you run the machine longer without having overtime and agency workers, or extra help. Make sure your specifications are complete and follow the project plan. So first and foremost, make sure you have your risk assessments in place. Going back to that slide a few slides ago, you need to make sure you have considered the risk assessment for yourself, your staff, your suppliers, everyone that's going to be working with that automation equipment needs to be included. Cost to make the machines automation ready. So, infrastructure, network, training, maintenance, all these things need to be taken into account, utility, upfront costs, etc., to make sure that the machine and the location is ready for that automation. And that goes a little bit into the cost for automation. So include the scope for readiness and safety. Again, making sure those risk assessments are carried out and actually everything is in place ready for it. And then finally, look at the installation, commissioning, programming, and warranty and training costs. So with that one, you want to make sure that you have everything ready and have taken everything into account in terms of the cost that you might see. Source the best fit solution at the right cost. So there's a balance between flexibility, variability, and the cost that you're willing to pay. And you need to make sure that the equipment that you're buying, or at least looking at buying, is the right one for you. So suppliers, they can promise the world, and it's not always the case that those things can do what they say. Coming from a development background, it's important that you test the suppliers and what they are suggesting, because once it's on your shop floor, it's yours. The problems are yours, and you need to make sure that you had it right in the first place. And then, coming from a development background, again, I can't stress how important it is that you validate the equipment, you test it, you review and optimize it. There's never a case where you install the equipment and right off the bat is perfect. You'll need to make tweaks, and you'll need to make modifications here and there to make sure it's running correctly for your particular process. And to kind of back that up, make sure you have warranties and backups in the contract in place, because again, once it's on your shop floor, it's yours, and you have to deal with it. So as I mentioned, or as Ryan also mentioned, at the start, you can HowToRobot can assist you on your journey, your automation journey, and we can work by matching you with companies that have the right automation solutions to offer. We can help you specify your needs and put them in the correct kind of forms and correct documentation. But if you want any more information, you can either use the website there, contact myself or Ryan or Elias, and the email, the kind of information is on the screen just there. I realize I've run quite a bit over time. I'm hoping there is some time for questions. If not, we can always follow up later on, but I will hand back over to Ryan for now.
Great, thank you, Sohabe. If anyone has questions, please write them in the chat box, or if you can think of questions after the session, reach out to us and we'd be more than happy to help. Sohabe, one initial question that may be helpful to address, if someone has been to a trade show or trade shows and hasn't found the right solution, perhaps they're not looking in the right place, what would you recommend in that case?
Good question. So actually, we have good examples of this, and actually a previous client is very much this one, where they spent a year going to trade shows and robot shows, and they've been asking companies, can you automate the process of sorting this? So this particular client is in the waste sorting business, and the problem here we saw was that they were going there and they were just taking a picture of their kind of plant, saying, can you do this? Now, most of the robot companies, most of the automation suppliers said, we can't do this. So they hired us to help. And we went in and we looked at the process. We mapped out what was going on, where the material flows were, what was actually being picked, and what were the dimensions, the sizes, the weights. And we split everything up into a very logical kind of process and flow. And we took those back to the suppliers. And actually what we found was that the suppliers were, oh, actually, we can do that. It's just that we didn't understand what the the requirements were first. And actually, one of the suppliers that initially said no now came back and said yes. So here, it's not about, what's your approach. It's about framing it in a particular way, or framing it in the correct way, and having those requirements in place that you need to understand before you go off to try to look for the solution. Because if you just go for a shopping trip down to any supplier, you won't find the right one. You won't understand what you're looking for. And this is the things that go back into that, what the 5 steps that we had before.
Perfect. Question from Rob. Do you have links to funding streams that may be available?
I'm not sure the question. So in terms of funding for...
Okay, I'll come in. No, if there's any funding grants or anything like that that are available either through government or one of the many agencies out there, do you have links as a business into those as well?
I'm not sure we do. That might be something for you, Ryan.
Yeah, we can follow up with you afterwards here, Rob.
Okay.
All right. Any other questions during the session? Otherwise, again, feel free to contact us afterwards, and we'd be more than happy to help. But thank you again for joining. And we hope you had a good time and learned a lot today. Thank you, Sohabe, for your presentation, and thank you again, Rob, and the rest of the BSSA for having us today.
No, thank you very much for giving this presentation, for attending, and I wish everybody a very pleasant rest of the day. Okay.